You can describe histograms in terms of their shape. 3 types are shown below. Note the top histogram is considered uniform because the heights of its bars, are all relatively close together. The middle histogram is called symmetric because its data seem evenly distributed around the highest bar in the center. And the bottom, skewed, because the data seem lopsided. There seem to be more data on one side of the middle than on the other. Example problem 3. Interpreting histograms. Is each histogram uniform, symmetric, or skewed? Example A. Here's a histogram. It seems very evenly distributed from left to right, and it doesn't seem to be uniform, so we would consider that histogram to be symmetric. The book describes that. The histogram is symmetric because the halves are close to mirror images, meaning if we were to consider dividing this histogram into 2 halves vertically, and one half seems to match the other, they're symmetric. And if we were to fold the histogram onto itself, it would pretty well match. Doesn't have to be perfect, but pretty well match. And B. Note this histogram seems to be lopsided. There seem to be more data on one side or on one end of the graph than on the other. So this histogram would be said to be skewed. The book describes it. The histogram is skewed because the peak is not in the center. And a chance to show that you have got it. A. The following set of data shows the numbers of dollars Jay spent on lunch each day over the last 2 weeks. Make a histogram of the data. Is the histogram uniform, symmetric, or skewed? And B, a reasoning question. How much money should Jay plan to bring for lunch next week? Explain your reasoning. A cumulative frequency table shows the number of data values that lie in or below a given interval. For example, if the cumulative frequency for the interval 70 to 79 is 20, then there are 20 data values less than or equal to 79. Example problem 4. Making a cumulative frequency table. The numbers of text messages sent on one day by different students are shown below. What is the cumulative frequency table that represents the data? We have the data set here representing the numbers of text messages sent in one day by different students. We'll consider the steps as outlined here. Step 1 says to divide the data into intervals. The minimum is 0. Notice there were at least 2 students who sent 0 text messages during the day, and the maximum is 49. You can divide the data into 5 intervals. Note that works well for this distribution. Step 2. Write the intervals in the first column. This will work just like a typical frequency table. So intervals in the first or the far left column, and then record the frequency of each interval in the second column. Again, constructing a traditional frequency table. Step 3. Add a third column, and this column represents the cumulative frequency. So we will add the frequency of each interval to the frequencies of all the previous intervals. So note, the number of students sending 0 to 9 text messages was 11. The number of students sending 10 to 19 text messages was 3, and so we add 3 to 11 to get our cumulative frequency. And then 14 plus 3 gives us 17, 17 plus 2, 19, and 19 plus 2, 21. And a chance to show that you have got it. What is a cumulative frequency table that represents the data below? And your lesson check for this section.